Hi friends and welcome in this new section, Security Fundamental Concepts. I try to give you the important terms. First, we have cryptology, is a discipline concerned with data communication and storage in secure and usually secret form. As we see, cryptology divided into two main classes. We have cryptography and cryptanalysis. Cryptography is a discipline which we try to hide the data by using special algorithms. This data not accessible but legitimate user. Cryptanalysis is the opposite of cryptography. Is a discipline which we try to break the algorithm and reveal the data before reach into legitimate user. We can also divide cryptography into two main classes. We have symmetric encryption and asymmetric encryption. So let's see what we meant about symmetric encryption. As we see in this figure, in a symmetric encryption, the key encryption is as the same as the decryption key. So I use the secret key to encrypt the plain text. After I encrypt, I obtained the cipher text. I use the same key to decrypt the cipher text into plain text. So as we see here, same key, secret key for encryption, the same as the decryption key. So let's move into asymmetric encryption. In asymmetric encryption, we have two keys, public key and secret key. We use public key to transform the plain text into cipher text, as we see here, public key for encryption, and we use another key to decrypt the cipher text into plain text. This key will be secret. We can all use the same public key, but to decrypt this cipher text, each one has his or her own secret key. Let's move into some encryption algorithms. First, we have scissor cipher. Is a symmetric algorithm, is one of the simplest and most widely known encryption techniques. It's a type of substitution cipher in which each letter in the plain text is replaced by a letter, some fixed number of positions. So as an example, we have a hacker as a plain text. I show you how you can reach into this cipher text using scissor cipher. As we see here, right shift by 1. So I take each character and I shift each character by 1 into right. For example, A become B, H become I. So let's see. This is the alphabet. H become I, and this A become B, and C become D. Here you can shift by any number. You can shift into right, and also you can shift into left. So let's move into another algorithm. We have route 13 is another single alphabet substitution cipher. All characters are rotated 13 characters through the alphabet. For example, phrase a cat become like this. So I take each character and I shift into right by 13. So this is route 13 algorithm. So here, for more understanding, A become N. I shift A into right by 13 character. The same thing for the rest. We have multi-alphabet substitution. A slight improvement in scissor algorithm cipher was developed, also called polyalphabetic substitution. In this scheme, you select multiple numbers by which you shift letters. For example, if you select 3 substitution, we have this number 11, 22 and 13. The cuts become like this. So the first A, right shift by 11 and C by 22 and A by 13. As we see here, we have 2A, but in encryption results, each A has a different letter. So this multi-alphabet substitution, as we see here, is an improvement of scissor algorithm. I shift T by 11. So when I finish, I start from the beginning. So let's move into rail fence algorithm. The rail fence cipher might be known the most widely known transposition cipher. You simply take the message you wish to encrypt and alter each letter on a different row. So, as an example, we have this plain text. Attack down is written as. So here we have 2 rows. I write here A, double T. I attack, as we see here. I make this line. A, first T, second T, A, C, K. At, as we see, at, and here D, A, W, N. To encrypt this plain text, I put here the first row and the second row. The first row and in the W, and I began with row 2. So how we can now decrypt this ciphertext? In order to decrypt the message, the recipient must write it out on row. So I write the first row here, as we see, and from here I write the second text in the second row. The recipient reconstructs the original message. Most texts use 2 rows as examples. However, this can be done with any number of rows you wish to use. So let's see the last algorithm in this video. We have Vigenere. Is a polyalphabetic cipher and use multiple substitutions in order to disrupt the letter and word frequency. The plain text attack at down. The person sending the message chooses a keyword and repeats it until it matches the length of the plain text. The keyword, in our case, lemon. So I repeat this word until it matches the length of the plain text. How I can get this cipher text? We use this table, Vigenere table. So here I cross A with L. So this A, and let's search here for L. As we see, this is the ciphertext. Let's see T with E. If I got X, I began with T, and here E. As we see, I got X. Let's see T with M, T, and this is M. I got F. we continue like this until we reach into the end of the plain text. So now how we can decrypt this cipher text using this key to obtain the plain text. I show you how you can do that. Now I begin from the key. So I search L. So here this is L, and here let's search for also L. So this is L and this is L. I obtained A. This is the first character in plain text. So let's see the second character. I begin from E and search for X. This is E, and here I search for X. This is X. I obtained T in the plain text as we see here. So let's see this. Here we have M with F. This is M. Let's search for F. This is F. I obtained T. We continue like this until we reach the end of the cipher text. So we will continue in the next video.